Well, hello everyone. Thanks for joining my talk. It is going to be about benefits of Hadoop as platform as a service. I've been working during the last 2 years on a big data project about characterization of big data deployments on the cloud and on-premise. I'll talk about this later. Right now I'm from the Barcelona Supercomputing Center. Probably most of you doesn't know about it, but for sure know about Barcelona. It's like our keyword to get attention. So basically, BC is a company a little bit different than the most that has been around here. It's a research center. So our goal is not to make a product in itself, but basically we are academic researchers. Its background started like 23 years ago with a collaboration between the Polytechnic University of Barcelona and many researchers and many companies such as an IBM. They founded what was known as the European Center of Parallelism of Barcelona. It was mostly focused on HPC and computer architecture. So that's mostly our background. And because of this collaboration, after the years, IBM decided to host what was, in that time, one of the most powerful supercomputers of the world on Barcelona. And of course, having this kind of technology required a management, and for this management, they funded what it is known as the Barcelona Supercomputing Center, which is in charge of providing services to the academic world and as well to the industrial partners that we have and to provide the resources. The center is led by Mateo Valero. He's a widely known researcher, mostly on the HPC and computer architecture areas. He has been awarded last year what is known as the Nobel Prize of HPC. It is the first European to win it. And he's also known as a lot of more awards, but basically the most important ones are the Ecker-Matsui Award, the Google Award, and he's as well an ACM fellow. So at BSc we have a large research staff that has produced more than 1,000 publications on the last 5 years because it was funded on about 5 or 6 years ago. We have a research staff of around 300 or 400 people working in it between academic researchers of the university, private researchers, as well as engineers. So on BSc, we don't only do HPC, but we also have several more areas, such as earth sciences, life sciences. One of the projects that we have been doing is computational genomics. And because of that, the biologists that we have found some patterns that may help to cure the cancer. And another interesting project that we have is the Human Brain Project. They are basically using the supercomputer to try to recreate how the human brain works. So it's a huge neural network. And they are trying to apply this kind of technology to solve the current challenges. But we are here to talk about Hadoop. So the Hadoop research at BSc started in 2008. It started with an SLA adaptive scheduler. So basically, you have several jobs that you want to run on your cluster, but you have deadlines of these jobs or maybe some other SLA parameters. So you hand it into the scheduler these parameters, what are the parameters for each job, and it tries to schedule the job so it fulfills the requirements. All of this research has been done on the data-centric research group. And the main project that I'm talking about here is the Alia project. This talk is going to be inside the project Alia. And the idea is to try to provide mostly, let's say, it's mostly an industrial talk, is to say you have like IaaS deployments or you have on-premise deployments. But right now there is a lot of ongoing work on platform as a service. So basically, you should get performance service, or maybe you should keep on with your on-premise cluster or your IaaS deployments. So but this is a challenge that Alia tries to solve, and basically Alia tries to automatically characterize the behavior of big data deployments and analyze its cost effectiveness. Basically, the important thing is that yes, you may deploy a large cluster, you need a super good guy, it can perform very well, but then you go to your manager, you say, okay, with this cluster we are gonna speed up our business like speed light, and then you tell your manager that it costs 2 million euros per hour. So of course you will say this is not possible. So the problem is the price. So you have to get a trade-off between the price and the performance. So Alia tries to provide tools and a repository environment where it tries to solve this problem. That is a big challenge, basically because you have many possible configurations. Hadoop as a starter has more than 100 parameters, software parameters like input-output file buffer, number of replicas of the file, where you want to store your intermediate files, and all of that has a direct impact on Hadoop, but not all of these parameters are the most important. So you have to try to find out which are the small set of parameters that really impact your performance. For this has been done a lot of research, and there are many papers of a lot of several researchers on several institutions. And we have a small set of 7-8 software parameters that impacts directly on the performance of Hadoop. But the point is that it's not all about software, but then you have the hardware configurations. Especially in the cloud and on-premise, you can decide if you want classical SATA drives, if you want SSD drives, if you want networks with InfiniBand or with Ethernet, if you want clusters of 30 data nodes or maybe 1,000 data nodes, if you want more cores or more RAM. And all of this has a direct impact on the performance of Hadoop and on the required tuning of the software parameters. So this is a real challenge, and that's what Alia tries to help. And for this, we have been running on these 2 years thousands of executions. Like right now, I think there are more than 60,000 executions that we have. And we have put all of the data that we collect for every execution, we make it public through a portal. So since we are researchers, we are interested in providing knowledge to everyone. And one of the things that we have are several machine learning tools. We have several statistics charts, etc. So you can try to figure out how they behave. So one of the things that we have learned on infrastructure as a service is that there is no single configuration that is good for all of the workloads. So for instance, here on the left side, you have different configurations of drives and network configurations. And it's not very clear on the chart, but basically those are 4 benchmarks. And I want to focus on the orange one. The orange bar is basically word count. If you are on the blue side, most at the right of the blue side, it's the best configuration possible. If you look at the orange one, you see that there is no huge difference between the configurations. This is basically because word count is all about CPU. So if you put more network, better network, or better risk, doesn't have a huge impact on it. But if you get the blue one, which is basically a benchmark that stresses the input-output file system, then you get that, of course, you want as the best network possible, and you want the best disk possible. So what this is showing is that if you get the best configuration for this benchmark, you are going to perform very good on this, but on word count you are going to get not as much as on the worst configuration for it, but in cost-effective terms, it's going to be much cheaper, and you are getting more or less the same performance. So you cannot decide a single configuration and put it in all of the workloads. It is not cost effective enough. On the right chart, you have more or less the same for the TeraSort benchmark, which is input-output, and you can see the impact on the disk. Since this is input-output, it has a huge impact to have the file system locally, or at least the temporary files, which are the bottom 3 bars, are storing in remote disk, but the intermediary files on the local disks. And this has an impact, because when you go absolutely fully on remote, you start to lose on it, because you have, since TeraSort is already IO bounded, if you get the worst IO possible, it's going to be bad for you. So what are the differences on Pathfinder service? Well, Pathfinder service basically tries to solve this problem at provisioning time. It's going to provide you a cluster when you deploy it that it has already configured Hadoop in the best possible way for this hardware. This is, of course, in an ideal world. And the point is that it removes the cost of installation, which can be already quite enormous cost for your business. And as well, it provides the maintenance. So you don't have to hire a data engineer to take care of anything that can fail on your Hadoop installation or anything that you need to tune up, because it's basically provided by the cloud provider. And hence, you are gonna reduce your TCO. And as any other cloud service, of course, you pay as you go. So how much, I tried to quantify how much can you, in ideal conditions, save. And I got the survey of really that published, I think, in 2014, that basically has a lot of information of the average salary on data science and data engineering. And I got that more or less in the US, the average salary is $140,000 per year. And then I took a cluster of 16 data nodes on Azure Edge Insight Service with S3 machine, which is a cluster that I found on the many executions that is one that has a better trade-off between performance and cost. So it's one of the most cost-effective clusters that I have found. I take the cost of this cluster per year, and I take around $40,000 per year. Then you make the difference, and you can get that basically you can save potentially $1,000 per year, $100,000 per year. But of course, this is an ideal condition. It's assuming that basically the cluster is already tuned for your very specific workloads. It's far from the real world, because the provider cannot know about all of the workloads and you need for all of them. So Pathfinder service has been an increasing investment on many cloud providers. We have several services. We have the Microsoft Azure HD Insight, Rackspace CVD, Amazon Elastic MapReduce, the Google Platform, Cloud Platform, and many other providers that are focusing on it. And they provide services of Hadoop, the classical MapReduce. They provide Test, Hive, and several other SQL on Hadoop and on Yarn technologies. And they are also providing already Spark and Storm and many other real streaming applications. So basically, they are trying to get the newer technologies on the big data area, and they are trying to get it into provide it into a Pathfinder service. So this means the Pathfinder service is it has something very good for business, because otherwise they wouldn't invest so much on it. So how do we know if it's the best for us or not? So for this, we have done the same that we have done on Alia, basically running executions on Pathfinder service. Our evaluation environment is basically Linux-based clusters. We have got a few data nodes cluster sizes. We have tried basically 2 cloud providers, Azure and Rackspace. And basically, because those providers, we already had executions on IaaS, so we can get the difference between them. Then we have clusters of every node with up to 8 cores and up to 64 gigabytes of RAM. And the main difference between the 2 providers is the way that they do the HDFS. So on Rackspace, you get local disks, and on HD Insight by default, it's the Windows storage. But both of them and most cloud providers have the advantage that you can change the configuration as you please. So if you want to store it all in remote because of the services of backup and etc., you can do it without problems. So we have tested basically two workloads. One of them is word count. It's interesting because word count is CPU intensive. This chart is basically showing it's monitoring the CPU usage during a word count execution. The blue part is the CPU usage spent on user part, so basically on the application itself, on word count. And you can see that all the time it's on the blue side. This means that all the time it's CPU. And this is good not in general to evaluate general business case, but it's good to evaluate if the providers scale on larger sizes. Because ideally, if you get twice the computing power, you should get twice the performance. So this already provides insights on if the providers are doing a good job on their different VM sizes or not. Then the other workload is the Terasort. It has become kind of a de facto standard on the community to evaluate the performance of big data deployment. Basically, it has become such a standard because it combines CPU power with I/O intensive power. So it's basically I/O intensive. It is such as this because Terasort, it splits the large set of numbers that you want to order on several chunk sizes of the size of an HDFS block size. Then it orders them, stores them back on HDFS, and then retrieves both of them at the same time on every map or on every reducer and merges them. So it's basically constantly retrieving from HDFS and storing on it and so on, and at the same time doing CPU power to order every chunk. And on the end you get the full data set ordered. So this performance can already show that basically it has an important CPU spent on user usage, but you also have a lot of I/O usage because of this part that when you do the first step of merging the small chunks, you are then storing them on HDFS and starting to retrieve them back. And this is shown on the red part, which is the input-output weight. So on this workload, we have been testing data sizes from 1 gigabyte to 1 terabyte. And we have seen that this reduced evaluation environment, it is enough to stress the system, which means that basically if you get twice data size or twice or a much larger cluster, you can already see a pattern. So you can already predict what will happen with larger clusters. So there's no real need to get a cluster of 1,000 data nodes, because with what we already have, with our tools, we can already predict how it will behave. But if you get the difference between 1 gigabyte and 10 gigabyte, it's enormous, and the behavior is totally different. That's why it was important to do so many tests. So one of the challenges that we have is the cloud variability. The problem is that if you get a run on any of the services and you do it again with exactly the same conditions, the execution time will be completely different. For this reason, we had to take several samples to try to get the pattern and try to predict how it behaves. So the standard deviation, as you can see here, it's already on percentage of the average time all of the executions. It's 60%, 28%, 55%, 47%, which is quite a lot. And this was a real challenge to solve, to try to figure out how it behaves. So as a starter, we have, thanks to our machine learning guru, we have a factor tree that basically is an algorithm that tries to get which is the parameter that changes most the performance times of the executions. So with the algorithm, you can get in this sample, it basically, of all of the runs, it's telling you that if you change from an SSD drive to a SATA drive, the performance difference is a lot. But if you get different input file buffers, it's always very important. It's also very important, but not as important as the disk type. So this was a first step to try to evaluate how performance service behaves. And this is just a small part of the chart that we got. Basically, I wasn't able to put the whole chart because it will take a whole wall, so it's too big. But what this is showing already is that the input file buffer is very important. It's basically the most important parameter. And second of it is the data size. So if you change the input file buffer, will change completely the performance of the executions. Another thing that is very important is that you go into the last important parameter is the clustering itself, the ID cluster. The ID cluster contains the number of data nodes, the number of cores per node, and the RAM per node. So what it will be very tempting for a technical person on this talk is to compare how the two providers behave. But as you can see on this chart, this is not the point of the talk, and plus is not really relevant because it's saying that it's the whole set of parameters of data nodes of VM size what it matters. It's not really the provider has not it hasn't an impact on it. But data size, on the other hand, changes a lot of the behavior. That's what I was saying before, that, and this tree basically points it out, that really when you get from 1 gigabyte to 1 terabyte, the behavior is completely different. So you need to go as far as this to get the pattern and to try to understand how it behaves. And this is another chart. Basically, it tries to get the average execution time all of the executions we have on every input file buffer size. Basically, we only have these two because the others are from other. The problem that I had is that I had a database with IaaS on-premise and etc. all of it merged, and the chart basically gets all of the possibilities. But the only two possibilities that are on performance service are the last two. And it's showing that on 10 gigabytes, but the input file buffer changes a lot of the behavior. Basically, the smaller bar means the faster ones. On 100 gigabytes, we can already see that basically are more or less the same. Every bar, by the way, it's a different benchmark, Terasure or WordCamp. So 100 gigabytes performs very similar. It's not already a huge difference. And if we get to 1 terabyte, it's the opposite. Well, before it was better, bigger input file buffer. When you get to 1 terabyte, it's basically better the smaller one. I mean, yeah. Except for WordCamp, basically because WordCamp is CPU bounded. And it's CPU bounded, I mean, it's not important, the input file buffer. The other important factor was as well the replication factor. And it shows that basically for WordCamp, you want only one replication because it's CPU bounded and it is storing the data on the disk. So if you get only one disk to store it, it will be much faster than if you add input output on it. And if you get to 1 terabyte, you get that basically on Terasure it performs better when you have a higher replication level. Basically because you have more aggregated bandwidth. So how does it scale the data size on Terasure? So here it's already showing that when you get this, I split it into charts because basically are very different between the VM sizes. So on the first one of 4 cores and 15 gigabytes, you can get that the real difference becomes at 1 terabyte. It's when the execution time starts to be very slow. And here you can see for the rest of the cluster sizes that we have, and in all of them repeat the pattern that on 1 terabyte is when it becomes it starts to become really slow. So I wanted to know why it is this, and it is happening because all of the steps are done on the cloud, on the public cloud, which means that you are sharing your environment, your hardware environment, with everybody else. So maybe it's someone else at this moment of time is doing a lot of network operations on the same rack where you are. You might get limited because of that. Also, they have limitations on the Azure storage. Actually, last year I attended a conference where a Google engineer spoke about their service, and he basically was saying that because of the load that they had on their racks, on their network, they had to limit the amount of data that you can transfer on the storage account on a given interval of time, because otherwise everything was being saturated and all of the customers were being downgraded on performance. So this is an issue that probably those providers also have, that they have to limit you on how much data can you put on a given interval of time. So how much impact the data nodes on word count? As we said before, it's expected that if you double the compute power of it, you should get double the performance. And you can see in this chart that basically the execution time on every data node size. If you double it, you more or less get double the performance. It's much faster. And on TeraSort, on the other one, it happens the opposite. It reaches a point of a terabyte that, yeah, you get more performance, but it's not really as much as on the previous one. So you start to reach a point where it might not be really cost effective. Especially, I'm pointing out 2 points. This is the dashed bars are basically the cost of it, how much it costs per every hour. And you can see that coming from 8 data nodes to 16 data nodes, it's even more expensive on the larger cluster, basically because the extra performance that you are getting, it's not enough to compensate the cost of these larger clusters. So which are the difference on the cost of the cluster zone between IaaS and platform as a service? You can see that IaaS is cheaper, but it might increase the TCO, basically, because the maintenance is on your own. If you have any problems, you need a data engineer on it. You can see basically the different VM sizes, the equivalent ones on every provider. It is cheaper on IaaS than on platform as a service. On the other hand, on platform as a service, of course, you save the data engineers. So to conclude, we have seen that provider doesn't make a big difference. More or less, they more have the same problem. And the problem is that in the public cloud, we have these limitations that we cannot exactly know which are those limitations, but I have the hints of that conference. But anything else we should need to access to the internal infrastructure and the architecture to know how it is done and what is the real problem. And we have seen that basically a larger cluster can become more expensive than a smaller one. On the other hand, platform as a service allows you to save the maintenance, but you still have to tune it a bit. So we have seen those issues, so you need to get and tune the software parameters of Hadoop in order to solve these issues and to get the best performance for your workload. So while performance service should ideally solve this issue, you still have to do it a little bit based on your business. And hence, we cannot say you want performance service or you want IaaS. You have to get your workloads, you have to get the hints on this talk and try to do a little bit of this work with your given workload, try to characterize how your workload behaves, and you can then know if you're interested in performance service or not. So thank you very much. I don't know if you have any questions.
I'm just interested in the variability in the performance that you said on the platform as a service.
Yeah, I go there.
Was that on platform as a service, was that the same variability that you noticed on the infrastructure as a service?
Yes, and infrastructure, yeah, it's not here, but you are right. On infrastructure as a service, we also see variability, but it's not as much basically because you are setting up your software parameters and your hardware in the best way possible. which basically means that, of course, if you get in perform a service and you tune it with your given workload, you will be able to reduce the variability. But a little bit of variability is always there, basically because it's public cloud and you are not alone.
Yeah, but that's not a variability, that's a huge amount of variability.
Yes, indeed.
I mean, that would really concern me if I was looking at putting out something in production that needed to do something in real time. And like, there's no way you could provide any kind of SLA on that kind of variability.
Yes. So, any more questions? Yeah.
You say you run this several times. What is the number of runs that we are doing?
Between 6 and 12 times. Yeah, those were enough to get, if you get the average and you do two splits on the runs, you see more or less the same time. So it was enough to say that if I got so many times, I would get more or less the pattern. Okay. So anyway, I think it's on.